Dear students, so let's start our class. Before I start, please do let me know that you are able to hear my voice clearly.
Yes.
Absolutely. Okay.
Yes.
And I'm going to share a screen with you, and please confirm that you are able to view the content in the screen properly. Okay. Just going to share a screen with you. I hope all of you are able to view the screen properly, dear students. Could you
Yes.
confirm that you are able to view the screen properly?
Yes.
Yes, sir.
Okay, all right. So, as I was telling in the last class that today we will be discussing solution of inequalities using wavy curve method. Uh, but before that, we need to understand that what we are going to achieve. Wavy curve is a method, okay? But what we are going to achieve? Here, we are going to achieve solution to the inequalities of this form, as you see in the screen, that x minus a1 in the numerator you see that x minus a1 power n1 into x minus a2 power n2 into x minus a3 power n3 dot 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 up to x minus ak power nk. What is a1, a2, a3 up to ak? These are real numbers. And what are n1, n2, n3 up to nk? These are the natural numbers. That is what we see in the numerator. But what is there in the denominator? If you see numerator, we just see. Na? And denominator, you see, dear students, it is x minus b1 power a1 into x minus b2 power m2 into x minus b3 power m3 dot 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 up to x minus bp power mp. Like the numerator, what is m1, m2, m3 up to mp? These are the natural numbers. And what is b1, b2, b3 up to bp? They are the real numbers. And that is what we have expressed in terms of the next 2 points. If you see that in I comma mj belongs to capital N, that is a set of natural numbers, where I is equal to 1, 2, 3 up to k, and j is equal to 1, 2, 3 up to p. And what is there in the ai and bj? Ai and bj belongs to R, the set of real numbers, and ai is not equal to bj, because if for some case ai is equal to bj, you can get cancelled in the numerator and denominator. And we see that I is from 1, 2, 3 up to k, and j is from 1, 2, 3 up to p. And the third point is that we are making that, a1, a2, a3 in a very sorted manner. That is, a1 is less than a2, less than a3, dot 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 up to less than ak. And similarly, b1 is less than b2, less than b3, dot 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 up to bp. Okay. So what we are going to achieve? We are going to achieve the values of x for which this inequality is going to be true. That means, in simple statement, we can say solution to this inequality. That is what is the purpose. And to achieve this purpose, that wavy curve method is a very efficient and effective method. How it is, we are going to see first with an example. Because as you know, like the others, what I did in the last classes also, that things get, very simple when we take an example and try to understand this. Okay, so what we are going to achieve now, dear students, is that we will first consider an example and see that how we are going to achieve that, solution using wavy curve method. After that, we will come back to discuss the theory behind it. So what we are going to achieve is that, so let us consider a polynomial fx is fx equal to x minus 1 into x minus 2 into x minus 3 divided by x plus 1 into x plus 2 into x plus 3. What we are going to achieve? We are going to find a solution for which fx is greater than 0. The moment we find a solution for one inequality that is greater than 0, then you will see, dear students, that finding solution for greater than equal to 0, less than 0, less than equal to 0 is also very easy, straightforward. So what we are going to achieve now? We are going to see that how to find solution to this inequality, that x minus 1 into x minus 2 into x minus 3 divided by x plus 1 into x plus 2 into x plus 3 greater than 0. Correct, dear students? I hope all of you are able to view the screen properly, just confirming once.
Yes.
Okay, great. So first what we're going to do, dear students, is that, we need to make every term, okay, x minus something. So what you see in the denominator x plus 1, we can write x minus of minus 1. So that we need to write first. So for here, from here, what we can write? Numerator, there is no such changes. Numerator is as it is, x minus 1 into x minus 2 into x minus 3 divided by, in the denominator x plus 3, I am writing x minus of minus 3. And then we are writing x minus of minus 2. And then x minus of minus 1 greater than 0. Why I write first minus 3, then minus 2, then minus 1? Because this is the sorted order. Minus 3, less than minus 2, less than minus 1. That's why we wrote in the denominator in that order. Similarly, in the numerator, if you see, dear students, x minus 1 into x minus 2 into x minus 3, so 1 less than 2 less than 3 in that way. So far it is well understood. So this is what you need to express first. After that, we need to make a number line. So let me use a different color. So let me first draw a number line. As you know, dear students, number line is a straight line. And we take the midpoint as 0, and then with all the positive, real numbers right side of 0, it goes to plus infinite, and all the negative real numbers comes left of 0, goes up to minus infinite. Now, what are the points here, for which the numerator is 0 and denominator is 0? Numerator is 0 for 3 points, 1, 2, and 3. So we need to make these 3 points here. So this is the point 1, this is the point 2, and this is the point 3. And denominator is 0 for what all 3 points, dear students? It is minus 1, then minus 2, and minus 3. And dot dot dot, it goes up to minus infinite, and right hand side also it goes up to plus infinite. Now the next step, dear students, is that the values for which the numerator is going to be 0, we need to mark it as a filled up circle or inked circle. Okay, like this means what are the values for which the numerator polynomial is going to be 0? Is 1, 2, and 3. So this 1, 2, and 3 we will mark it as filled one. 1, 2, and 3, that we marked it as a filled one. And the denominator polynomial for which it is denominator polynomial is 0, the values, these are minus 1, minus 2, and minus 3. So this minus 1, minus 2, minus 3 should be unfilled circle, just like that, uninked circle. That means it is just a circle, no filled up. Done. After that, what we are going to do, dear students? We are taking a, just consider anything above the number line. Anything above the number line is always something related to greater than 0 or greater than equal to 0. And anything below the number line related to less than 0 or less than equal to 0. Okay, anything above the number line, it is related to the polynomial expression greater than 0 or greater than equal to 0. And anything below the number line, that polynomial is related to less than 0 or less than equal to 0. Now we are going to draw a wavy curve. So for that, the tip of that pin should be above the number line, right side of the rightest mode value. What is the rightest value is 3. So our tip of the pin should be here, which is above the number line and right of 3, anywhere, here, anywhere. So I just make it here. Correct, my dear students, here. And from here I started drawing a wavy curve. How I'll draw? From here I will approach the point 3. Let me use a different color, okay, so that it will be clear. Let me use a green color. So above the number line, right of 3, this point. So from here I draw and come to the point 3 and just stop here. Let's look. X minus 3 power is what? X minus 3 power is 1. 1 is odd. Hence I will cross the number line and go up and go down and then go up to 2.2, because x minus 2 is the next one. Now I said what? X minus 3 power is 1, which is odd. That's why I crossed the number line. Now what could have happened if the power is even? I should have jumped in the same number above the number line. I will show you by means of some other example later. In the next example, I will show you when the power is odd. Sorry, when the power is even. Then I come to the below the number line, come up to the point 2. Then what we see? X minus 2. X minus 2 power is what? 1, which is odd number. So I cross the number line from below the number line to the above the number line. Again go up and come down. Come to the point what? X minus 1. What is the power of x minus 1, dear students? Is 1, which is again odd number. So I cross the number line from above the number line to below the number line. Go down and again go up. Sorry, go down and then go up. What is the next point? Is minus 1. X minus of minus 1, which is actually x plus 1. What is its power? Power is 1, which is odd. So I'll cross the number line from below the number line to the above the number line. Go up and again come down, come to the point x minus minus 2. That is x plus 2. What is its power? 1. So I'll again cross the number line, go down and again come up and come to the point x minus minus 3. Its power is also 1. So I cross the number line from below the number line to the above the number line and done. My curve drawing is done. In this particular example, all the power of this numerator and denominator polynomial is odd. That's why we always cross the number line. Purposefully I took this example. Next example you will see some of the terms power is even, and we will see how we are jumping and being in the same above the number line or below the number line, will depending on the case, whether it is a numerator polynomial is power is even or denominator polynomial is even. Fine. Our drawing of this wavy curve is done. Okay, let me repeat once more with a different color. Let me draw the same curve with a different color so that you will get a different perspective. You will get the revision of this thing. So what I'll do first, I'll take a point which is above the number line right of 3, like this. And then I started drawing. From here, I will approach to the point 3. After coming to the point 3, dear students, what I see that x minus 3 power is 1, which is odd. As the power is odd, I will cross the number line. In this case, crossing the number line means what? Above the number line to the below the number line. So as I have crossed, come down, and then after some time I go up. Then I reach x minus 2. Power of x minus 2 is 1, which is odd. So again I will cross the number line. Here, what is the meaning of cross? Crossing means that from below the number line to the above the number line. I go up, and again come down. Come down to where? 1.1, which is related to x minus 1. What is the power of x minus 1 here, dear students? Is 1, which is odd. So again, I will cross the number line from the above the number line to the below the number line. I come down, and again go where? I go to the point minus 1. That is x minus minus 1, which is x plus 1. So what is the power of x minus minus 1? That is x plus 1 is actually odd, which is 1. Hence, I will cross the number line from below the number line to the above the number line. So as I cross from below the number line to above the number line, so I need to go up to come down. No? Come down to where? Come down to minus 2. X minus minus 2. Power is 1. That is x plus 2. Power is 1. So again I will cross the number line from above the number line to below the number line. I come down, come down, again go up. Go up to where? The point minus 3. Why? Because the next one is x minus minus 3, which is x plus 3. What is the power of x plus 3? 1, which is odd. So I will cross the number line from minus 3, from below the number line to the above the number line and go on. Done. So my wavy curve is drawn. After that, finding a solution for this entire polynomial expression greater than 0 is a matter of few seconds or maximum a minute. How? So here what we are going to find, fx is greater than 0. This expression greater than 0. No? So I will consider the above the number line. If you remember, dear students, I said above the number line related to greater than 0 or greater than equal to 0.
Yes.
So I will consider above the number line and look into the regions where it is the above the number line where the curve actually came. This is the above the number line. This is the portion. This is the portion, and this is the portion. No? These are the intervals you see the curve is in the above the number line. Correct or not? Okay. So what we are going to do is that means first interval. So this implies, dear students, x belongs to, first one is that minus infinite to 3, minus infinite to minus 3. Correct, no? Let me write it down very clearly here. This implies, from here I am coming, by the way. Okay. So this implies x belongs to minus infinite to minus 3. Then union. What is the next interval where it is above the number line? From minus 2 to minus 1, na, dear students? So union minus 2 to minus 1. Then union. What is the next interval where it is above the number line? 1 to 2. Correct, na, dear students? 1 to 2. Union. What is the next interval where it is above the number line? That is from 3 to up to plus infinite. So union 3 to plus infinite. Done. That is the solution set for which this polynomial expression fx is greater than 0. I said maximum within a minute, and that we have achieved. Now the question is that if it is greater than equal to 0, how it is? Very easy. If suppose we assume this is fx, no? This is fx. So if the solution you need to achieve for fx is greater than equal to 0, fx is greater than equal to 0. So what we are going to get it now, dear students? Exactly the above solution, but it is small, not exactly the above solution, almost the above solution, only few changes. So what I will write? First, let me write this one. That implies x belongs to, first you write this thing, minus infinite to minus 3, union minus 2 to minus 1, union 1 to 2, union 3 to infinite. After that, we need to change that open interval to closed interval for few points. The points where we marked it as a filled up circle, inked circle. That is the point here 1, 2, 3, not dear students. So instead of 1, 2, 3, what we are going to do? Instead of 1, instead of closed interval, I will write, instead of open interval, I am going to write a closed interval 1. Correct? And 2 is also like this. Correct, no? So I will just eradicate that closed interval and place an, eradicate the open interval and place the closed interval. Similarly to the point 3, not dear students. So what I'll do, 3 I'll eradicate, open interval I'll eradicate, left of 3 and introduce the closed interval. That means these are the points are included. That is the solution to fx is greater than equal to 0. Done. Any doubts, dear students, from anywhere at any point? Now, how to find fx is less than 0? Very easy. I hope you understand by analogy what will be fx is less than 0. Pretty simple. Fx is less than 0. What we are going to achieve? We need to find those regions where the curve is below the number line. If you remember, dear students, I said that below the number line is related to the solution for less than 0, less than equal to 0. So below the number line means where? This is a region which is below the number line. This is a region which is below the number line. This is a region which is below the number line. So very simple, minus 3 to minus 2. Minus 3 to minus 2, correct, no? Correct. Then union, what you are going to get? Minus 1 to 1, correct or not? Union, what is the next one? Can someone please tell? It is 2 to 3, correct? Exactly. Done. That is the solution to fx less than 0. The moment you find fx less than 0, then it is very easy to find fx is less than equal to 0. It is similar to the fx less than 0, only we need to change for few points from open interval to closed interval, correct now? So what are the points for which we need to change the open interval to closed interval, where the points are filled up circles? That is 1, 2 and 3, correct, dear students? So what it will be? X belongs to minus 3 to minus 2. It will be as it is because there is no filled up circle related to minus 3 and minus 2. Union minus 1 is left of minus 1 should be open interval, but right of 1 should be closed interval. Why? Because it is a filled up circle. Union, again, 2 left of 2 should be closed interval because 2 is a point where it is a filled up circle. And again 3 is also a filled up circle, so it will be the closed interval. That is the solution to fx less than equal to 0. I hope you get some idea. Now let's look into another problem. Correct, dear students? Any questions so far? Let's look into another problem. Let's have our idea very, much more, rock solid. And then we'll come back to the theory, that what are the things. There will be 1-2 corner cases that will come later, okay? But first, let's understand that exactly we come to know that how we need to approach this one. Correct, not your students? Huh?
Yes.
Absolutely clear? Okay, now let me take another problem and let's discuss on that one. Now the second example, what I'm going to say, take is this one. I'm just going to share it with you. Second example, that we are going to find a solution to the polynomial equation, inequation like x minus 2 whole square by x minus 1 into x minus 3 greater than equal to 0. Correct, not dear students? So what you need to do first, if you we just recap, whatever we have done. I'm just going to recap. First we need to draw a number line. So first we draw a number line. This is the number line we have drawn. And as you know, the number line midpoint is 0 and it goes up to plus infinite into the right hand side of 0. It goes up to minus infinite in the left hand side of 0. And what is the point for which the numerator polynomial is 0, dear students? It is 2, correct, no? So 2 has to be done with a filled up circle, correct? And what are the points for which the denominator polynomial is 0, dear students? It is 1 and 3. So 1 and 3 should be unfilled circle. Correct or not, dear students? Correct. Now after that, what we'll do, we will, as we need to find a solution, first we need to put our hand, actually the tip of the pen, above the number line and right of 3. So this is the point. Let me use a different color. Correct? This is a point which is above the number line and right of 3. And I start drawing. So first I get what? I come to x minus 3. What is the power of x minus 3, dear students? It is 1, which is odd. So I will cross the number line, come down and go up again, and what we get? X minus 2. X minus 2 power is 2, which is even. So I should not cross the number line. I should be there in the same number line. And what we'll do, dear students, what is the next point? What is the next point is 1, correct? So I will come to this one, 1. See, I jump, I didn't cross. X minus 2 power is 2, which is even, so that's why I didn't cross. I jumped that number. I actually jumped being in the same one. I jump to the next point, x minus 1. What is power of x minus 1? Power of x minus 1 is 1, which is odd, so I'll cross the number line. Correct now, dear students? All of you understood? My drawing of wavy curve is done.
Yes.
Anyone has any difficulty, dear students, please do let me know. Again, I can explain, okay, with a different color. Suppose I use a color of this thing, green. So first you understood the number line, and I plotted 3 points, 1, 2, and 3. 1 and 3 are unfilled circle. Why? Because they are the points for which the denominator polynomial is going to be 0. Whereas the point 2 is filled up circle. Why? Because this is the value for which the numerator polynomial is 0. Because if you apply x equal to 2, you see the numerator polynomial, that is x minus 2 whole square, that is going to be 0. So that's what we have made 2 as a filled up circle and 1 and 3 as, just blank circle, unfilled circle, uninked circle, the way you can name it. After that, what we are doing, dear students, we know from a principle is that we need to take a point which is above the number line and right of the maximum value, which is 3 here. So I took that point here. Okay, then I started drawing. I will start draw, come to the point 3. I come to the point 3, that is x minus 3, and then look into the polynomial expression. What is the power of x minus 3? I see the power of x minus 3 is 1, so I will cross the number line. Crossing the number line from above the number line to below the number line, that means I need to come down, na? Come down, again go up. And what is the point I get? 2. That is, now we need to look into the polynomial, and we see that is x minus 2 power is 2, which is an even number. As it is an even, so I should not cross the number line. I should not cross the number line, I repeat. So I will be in the same of the number line and jump to the next point, which is 1. Now I look into x minus 1. What is the power of x minus 1? Is 1, which is odd. So I will cross the number line. Done. My wavy curve drawn is done. After that, only greater than equal to 0 solution I need to find. And dear students, we discussed anything above the number line related to greater than 0 or greater than equal to 0. So I only bother about the region above where the curve is above the number line. So this is one region, this is another region. Correct or not, dear students? Tell me.
Yes.
So what will be our solution set then? This implies x belongs to greater than equal to 0. It is not greater than 0. So first we'll make minus infinite to 1, na, dear students? Minus infinite to 1. That means this is the region we have covered. Correct, na? Then we get from 3 to infinite. Correct or not? Union 3 to infinite. Correct or not? Then this region is done. Now there is a single point which is left out, which is 2, for which expression is 0. So we should include that value 2 also, a singleton set. Correct, na? Because if you apply x equal to 2, then you will get that the value of the polynomial is 0, na, which satisfies the inequation greater than equal to 0. Are you getting my point, dear students? So we can write this thing in a little, organized manner. That is minus infinite to 1 union the set 2, singleton set, singleton means set containing only one element, that is 2, and then 3 to infinite. Clear or not clear?
Yes.
Now suppose the question is given like this, that we need to find, let me use a different color, we need to find x minus 2 whole square divided by x minus 1 into x minus 3 is less than equal to 0, for example. Not a big deal. What we should concentrate? We should concentrate where it is below the number line, the portion of the curve where it is below the number line, correct or not? So these are the two mark what I did now in that purple color below the number line, this and this, correct? So very simple. From here, what you can say, x belongs to, first we will make it from 1 to 2, correct, not dear students? Correct. So 1 should be closed in open interval and 2 should be closed interval. Why? Because less than equal to 0.
Yes.
If it is less than 0, then I should have write open interval right up to. Open interval, that symbol. Union. Then what we are going to get? We are going to get 2 to 3. Correct or not? 2 to 3, but 3 should be open interval. That means what? That means actually it is from 1 to 3 open interval. Correct or not? If you see, this thing is nothing but open interval 1 to 3, because 2 is also included, no? Correct or not?
Yes.
But if the question is there, okay, all the cases let us study now, no? Suppose if the question is something like, that x minus 2 whole square divided by x minus 1 into x minus 3 is less than 0, not less than equal to 0. You see what is the slightest change here? X belongs to, it should be minus, it should be 1 to 2, but 2 should be open interval.
Yes.
Because it is less than 0.
Yes.
Union, again you will get from 2 to 3. Correct, na? Now here you cannot merge 1 to 2 open interval union 2 to 3 open interval doesn't mean that open interval 1 to 3, because 2 should be included then, na? So here it will be the solution set. Understand the fine line difference. Absolutely clear, dear students?
Yes.
Okay. Now, I want to go for the next one, next example. Correct, dear students? I hope all of you have some 10-15 minutes more time.
Yes.
Okay? So that we can discuss more elaborative manner. Okay. Third example, and it will be little bit of more relatively complex, I can say, but it is very easy to solve if you understand the steps. Let me show you. By looking into the problem, you will find it is relatively complex, but it is not actually. But solution will be very easy because we know the method. Okay. Look into this, dear students. Suppose we need to find solution to this inequation. So, first and foremost, if you recall the theory in the initial what I said, that we need to make that x minus something. You see here, dear students, there is a term called 6 minus x.
Yeah.
So better I should write x minus 6.
Yes.
If we write x minus 6, then minus 1 power 1 to 3 1 should be multiplied, na? Correct or not? Then what we are going to get? We are going to get that, -1 power 1231. The moment you are going to do it, then you will find that it is actually sign of inequality will get changed. Correct or not? I'll show you. So we need to rearrange that inequality in this manner. So how to rearrange this inequality? Let me first show you that how I am rearranging this inequality. I will explain each and every step. Let me first put this one, and I'll explain each and every step and why it is required to make this in such manner. Look into it, dear students, slowly, no hurry. And I'll justify why this rearrangement happened like this. First of all, we will rearrange the given inequality as below, as mentioned here. X into x plus 5 power 2016, x minus 3 power 2017, 6 minus x power 1231, as it is in the numerator I have written so far. Then denominator, what I am writing is that whatever the initial expression is given like this. Now, if you recall the theory, now I can go back quickly, that everything I need to express in terms of x minus a power n1, x minus a2 power n1 means x minus something. Correct, na? But if you look into this particular example, it was x, the first term in the numerator. So I wrote x minus 0. Correct, na, dear students? So that's why I wrote x as x minus 0 power 1. This one, dear students. Then x plus 5 power 2016. That I wrote as x minus of minus 5 power 2016. Then x minus 3 power 2017, that I wrote as it is, x minus 3 power 2017. Next term is that 6 minus x power 1231, that I wrote as minus of x minus 6 power 1231. Correct, dear students? And denominator is x plus 1 power 2015, that I wrote x minus of minus 1 power 2015. This one. Then x minus 2 power 10,000 as it is. And then x minus 4, that initially it was 4 minus 6 power 242. So we wrote x minus 4 power 242. Both are same. Why, dear students? Because 242 is an even number. And minus 1 power even is always plus 1. Got it, no? So 4 minus x power 242 and x minus 4 power 242, both are same. So I hope you understood this part and this part also. Any doubt so far? Dear students, please confirm. Till this part, you do not have any difficulty in understanding. Yes. Disha, absolutely clear? Dear Disha, Srijita, Sagnik, Divansu, Mohan. Absolutely clear till this?
Yes, sir.
Okay, great. After that, what we are doing is that, you see there is a minus here in the numerator, this minus. So we are multiplying both sides of the inequality by minus 1. Then what will happen? Sign of inequality is changing from greater than equal to 0 to less than equal to 0. As we have multiplied by minus 1. Correct? Yes. So now this is a proper form, standard form, we can say. This one. So x minus of minus 5 power 2016 into x minus 0 power 1 into x minus 3 power 2017 into x minus 6 power 1231 in the numerator. Denominator we get x minus minus 1 power 2015, x minus 2 power 10,000 and x minus 4 power 242. Correct, dear students? After that, what we are going to do? So this problem now reduces to finding a solution to the inequations fx less than equal to 0, where fx is this, as you see. Correct? Now, it's pretty simple how to form a solution. It will take few minutes. How? So all these big power, don't get, at all, worried about this thing. Power 2016, power 1231, power 10,000, 2015, sir, what will happen? Nothing will happen. Only point is that whether even or odd, you can say or not, which is a, fourth or fifth standard mathematics, to finding whether the number is even or odd. That's it, as simple as that. So what do we need to do first? We need to first draw a number line. Correct, no? Yes. So first we will draw a number line. Let's draw very well a number line. Draw. If you want to draw wide, you can draw, no problem. And midpoint is 0. See, always I go back with the fundamental. Right of 0 is goes and up to infinite. Left of 0 is goes up to minus infinite. And what are the points here, dear students? Minus 5, minus 4, minus 5, 0, 3 and 6. Correct or not?
Yes.
So we can make a relative measurement. Minus 5 is this point. Suppose for which it is 0, na? The numerator is 0 for minus 5, so it is filled up circle, that is minus 5. Then point where numerator is 0, so that is also filled up circle, 0. Then next point is 3, na, dear students?
Yes.
That is also, it will be 0. And the next one is, 6. 6 is somewhere here, that is also 0, correct?
Yeah.
So that's why it is filled up circle. Filled up circle means the circle which is inked one. Then let's find the points for which the denominator is 0, dear students. So there are 3 points. One is minus 1. So minus 1 will be here, na? So it will be unfilled circle. Minus 1. Then the next point is 2. 2 should be here, na, dear students? Unfilled one, uninked one, empty circle, the way you want to name it. Next one is 4. That is should also be unfilled one. All of you correct, dear students? So with this, we are able to draw the number line with the proper pointing of numerator and denominator polynomials, number point for which it is 0. Where the numerator polynomial is 0, we make it the filled up circle. For which the denominator polynomial is 0, we make it the unfilled circle. After that, what? Very simple. We need to draw the wavy curve. So for that, let me use a different color. Let me use a green color. What you need to do? We need to put the tip of the pin above the number line, okay, and right of 6. So this is a point which is above the number line, right of 6. So now I start coming towards approaching the point 6. I come to the point 6. Let me draw a little better. So come to the point 6. What is seen in the 6? I see the point 6 is x minus 6 power is 1 to 3, 1. 1 to 3, 1 is what? Dear students, odd. As it is odd, I will cross the number line and come to the next point is 4, x minus 4. What is the power of x minus 4, dear students? 242, which is an even number. So I should not cross the number line. I should be there in the same number, same portion of the number line. Then what is the next point, dear students? Is 3, x minus 3. So I'll come to the point x minus 3. What is x minus 3 power? 2017, which is an odd number. So I'll definitely cross the number line. Go up and come down. Where I'll come? Come to the point 2. X minus 2. What is the power of x minus 2, dear students? 10,000. 10,000 is an even number. So I should not cross the number line. Rather, I should jump and go to the next point is 0. X minus 0. What is the power of x minus 0, dear students? 1, which is an odd number. So I should cross the number line. Then I'll go to the next point is x minus 1. X minus minus 1, that is x plus 1, that is x minus minus 1. What is the power, dear students? 2015, which is an odd number. So I must cross the number line. Then what is the next point I'll go, dear students? Is minus 5. What is the minus 5? X minus minus 5 power is what? 2016, which is an even number. So I should not cross the number line. Rather, I should jump and say like this. My wavy curve drawn is done. Correct, na, dear student? Anyone wants to be drawn one more time? Let me know. I'll draw. Otherwise, I'll go back to this. I'll directly go to the finding the solution. Anyone wants me to draw the curve once more? I can. Otherwise, I can go. I already explained a couple of questions like this. Then, dear students, what I'm going to do? I'm going to finding a solution. Very simple. What is the solution here? Fx is less than equal to 0, na? Less than equal to 0 means our concentration should be below the number line. If you remember that below the number line where we should discuss about less than 0 or less than equal to 0. Correct, na? Below the number line. So now below the number line less than equal to 0, let's find the portion of the curve where it is below the number line. This is the portion, this is the portion, this is the portion, correct? So what you should write? So solution from here, what you can write is that This implies x belongs to, first one is what? -1 to 0. Correct or not? So let's write -1 in the open interval because it is unfilled circle, and 0. 0 is closed because it is less than equal to 0. Less than equal to 0, that's why right of 0 should be closed interval. Then union. What is the next interval? 3 to 4. Correct or not? So 3 is filled up circle. So, and as it is less than equal to 0, it must be closed interval left of 3. But right of 4, it should be open interval because 4 is an unfilled circle. Correct, na, dear students? Then union. What it starts with? 4. 4 is an unfilled circle, so left of 4 should be open interval, comma, what is that? 6. 6 is the filled up circle, so it should be closed interval. Done. So what is the solution we get? So simple. -1 to 0. Okay. -1 to 0. 3 to 4. 4 to 6. And there is a one small catch. Can you tell me what is the catch? There is one point is there, which is an isolated point 5. This point. That also we need to include. Correct, na? So union, that singleton set 5. Correct? So what we get? -5, -1 to 0, 3, 4, 4, 6. Correct, na, dear students? Anyone has any simplest doubt, never hesitate to let me know. So this implies x belongs to, we can rearrange properly. So I'm sorry, it should be -5, not 5, -5. Correct? So what it should be? So it is -5. Then union -1 to 0. Correct? Then union 3 to 4. With 3 as the closed interval and 4 is open interval. And union 4 to 6. 4 is open interval and 6 is closed interval. Correct or not? Absolutely clear, dear students?
Yes.
Okay. Now, one more problem I am going to solve. And after that, we'll come back. Now, theory doesn't make much sense. You understand so well. Right? I hope. Let's look into the next problem, dear students. Okay? The next example, we are going to solve an inequality of this kind. Very important, dear students. These kind of questions generally come in entrance examinations. And as you know, it will be very easy thing to do. So what is the third example? Third example, if you see, dear students, it is x plus 3 into 3x minus 2 power 5 into 7 minus x power 3 into 5x power plus 8 power 2. And if you recall what I said, always make the coefficient of x as 1. If you look into the theory, if I take you to the theory, if you look into this, if you find x minus a1, x minus a2, x minus a3, x minus ak, in the denominator x minus b1, x minus b2, x minus b3, x minus bp, what is the coefficient of x? 1, right? Correct. And also it is always x minus. It is not x a1 minus x. It is actually x minus a1. If it is given a1 minus x, we need to convert it to x minus a1, which we did in one of the example here. You see, in this case, 6 minus x was there. Correct? Now we made it x minus 6. Similarly, here both the cases are there. So that is why I selected these examples like this. So first, what you need to do, dear students, we need to rearrange properly so that the coefficient of x is equal to 1 and that always it is x minus something. Correct, na, dear students? You got my point?
Yes.
So we need to rearrange. Like the previous one, we need to rearrange. So if we rearrange, it will be something like this. And here, I want to give you 2 minutes. You just go through it and understand each and every step that yes, sir, there is a proper justification why you have done this rearrangement. If you have any smallest doubt that why sir has done that, this kind of rearrangement, please do let me know. I am not going to explain you here why this rearrangement I have done. Why? Because I already explained for in the last few examples. So you please go through it, justify yourself that yes, that is the correct one, that why the rearrangement has been done like this. It is not because of that sir has done. That's why it is correct. Your understanding somebody, yeah, this is the way it should be done. Okay. And first you confirm that yes, sir, this kind of rearrangement makes sense. After that, we are going to solve it. I hope you agreed.
Yes,
Correct?
sir. Yes.
Now we are going to draw the wavy curve and find the solution. Correct, not dear students? So here, unlike the previous questions, there is no denominator here. Correct, not dear students? So as there is no denominator, so we can assume the denominator is 1. Actually, our problem is simpler now. So first we draw a number line. Okay, so this is the number line I'm drawing, dear students. So as you know, midpoint is 0. Right side of 0 is goes up to infinite. Left side of 0 it goes up to minus infinite. Now what is the first point it is coming? What are the points for which the polynomial is 0? It is minus 3, minus 8 by 5, minus 2 by 3 and 7. Correct or not? So suppose this is minus 3. Correct, not dear students? Then it is minus 8 by 5. Minus 8 by 5 will be somewhere here. You can make the relative positioning. You don't need to be exactly precisely correct in the number line. But the relative positioning is important. It should not be that minus 8 by 5 is left of minus 3. It should not be. No? Minus 8 by 5 should be right of minus 3 because it is more than minus 3. Okay, that should be. But exact precision point is not important as long as solution to this kind of inequality is concerned. Then it's 2 by 3. 2 by 3 should be right of 0. Correct, not dear students?
Yes.
So this is 2 by 3. And the next one is 7. 7 should be somewhere here, not dear students? Yeah. So these are the 4 points. And we have done these 4 points, filled up 1 because we considered this as the numerator. Denominator is 1. Now we are going to draw the wavy curve. Very simple. What is the first step for drawing the wavy curve? Let me use a different color. We need to put our tip of the pen above the number line, right of 7. Suppose somewhere here. Correct, not dear students? From there, I will start approaching the point 7. So x minus 7. What is the power of x minus 7, dear students? Power of x minus 7 is 3, which is an odd number. So I should cross the number line from the above the number line to the below of the number line and come down and again go up, come to the point 2 by 3. What is 2 by 3, dear students? X minus 2 by 3 power is 5, which is odd. As it is odd, definitely I'll cross the number line, dear students. I go up and come down. Where I'll come x minus 8 by 5. Power is what? Power is, 8 by 5 power is what? Power is 2, which is even. So I'll jump. I'll not cross the number line. I'll jump. Jump to what? Jump to the next point is minus 3. Correct, not dear students? What is the x minus 3 power is 1. 1 is what? 1 is odd number. So I should cross the number line and run. My wavy curve is drawn properly. Okay. Now what is our solution? Our solution, we need to find fx is less than equal to 0. Na, dear students? So if you recall anything below the number line related to less than 0 or less than equal to 0, so I should focus on the part of this curve where it is below the number line. So this is one part and this is another part. Correct, dear students?
Yes.
So how to find this thing? Very simple. So here this implies x belongs to, it should be minus infinite to 3, minus infinite to minus 3. Correct, na?
Yes.
Clear or not clear?
Yes.
Below the number line, less than equal to 0. So it should be minus infinite to minus 3. Minus 3 should be closed interval. Correct or not? Union, then it is 2 by 3 to 7. Correct? It is 2 by 3 to 7. Now, as it is a less than equal to 0, we need to include that particular point minus 8 by 5. Correct, na? So, union, the singleton set containing minus 8 by 5. That is the solution. Correct, na, dear students?
Okay.
So, as you understood all these things, theory become, now if we go back to discuss the theory, it becomes so simple. You will find, yes, I'm able to relate everything. That's why my style of teaching is that whenever there is something relatively complex, first explain with examples, and then we'll go back to the theory. That makes the theory also, now you can go back to the theory to the examples also. Now I'm coming to the first page of this, our, from where I started. Correct, not dear students? So what what is our first learning? So what we are going to do it here? We are going to find the solution to this inequality, as you see, dear students, here, that x minus a 1 power n1 into x minus a 2 power n2 into x minus a 3 power n3 dot 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 up to x minus ak power nk divided by x minus b1 power m1 into x minus b2 power m2 into x minus b3 power m3 dot 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 up to x minus bp power mp. That greater than 0 or greater than equal to 0 or less than 0 or less than equal to 0, this solution we are going to find. So what is the first step? So the few things you need to note it down is that make sure the coefficient of x in each factor is 1. That's the first point. Make sure the coefficient of x in each factor is 1. That means what? That means if you get something like this, in a specific example, if we get something like this, just have a look into it. If you get a, something like that 3x minus 2 power 7, so you need to rearrange. How to rearrange? You will make it 3 power 7 into x minus 2 power 7, x minus 2 by 3 power 7, correct, na? Or if you have a factor 3 minus x power 9, so it should be minus 1 power 9 into x minus 3 power 9. That is actually minus of x minus 3 power 9, because minus 1 power 9 is nothing but minus 1. So this you need to make this rearrangement. And for example, when you made 3x minus 2 power 7, so 3 power 7, you don't need to take any special case for 3 power 7, because 3 power 7 is positive. So if you divide, multiply, or whatever you do, sign of inequality will remain the same. You don't need to bother about this thing. Correct, not dear students? So now, what are the steps we are going to follow? So step 1, step 2, I'll explain first. And you will able to completely relate, because we have already discussed this thing with an example. Not only one example, 2, 3 examples we have discussed, right? 3 examples. So first thing is that let fx equal to this polynomial, as you see in the beginning, x1 minus a1 power n1 into x minus a1 power n1 into x minus a2 power n2 up to x minus ak power nk divided by x minus b1 power m1 into x minus b2 power m2 into x minus b3 power m3 up to x minus bp power mp. Step 1. All the zeros in the numerator of the function fx, that is all solution of the equation x minus a1 into x power n1, x minus a2 power n2, x minus a3 power n3 up to x minus ak power nk, should be marked in the number line with filled or inked circle. Correct, no? That's what you have done. Step 1, you are able to relate. Step 2, Step 2 says that the same following thing. I'm just going to show it to you here. Steps 2 says this that all the zeros of the denominator of the function fx, that is all solution to the equation x minus b1 power m1, x minus b2 power m2, x minus b3 power m3 till x minus bp power m equal to 0 should be marked in the number line with unfilled circle, that is uninked circle, empty circle. Correct, na, dear students? I hope you will relate it. That is a step 2. Then what is step 3? Let me bring that step 3, and after that I will explain. Okay. Okay. Now I'm going to read out the step 3, dear students. Find the values of fx for any real number greater than the rightmost marked number in the number line. Correct? That is what is actually above the number line, right of the rightest mode value. To tip of the pen should be pointed there. Now draw a wavy curve from right to left, beginning above the number line and passing through all the marked points, so that when it passes to a simple point, that is if the exponent of a factor is odd, that is called simple point, then the point is called simple point. The curve intersects the number line, that is you cross the number line, and when it passes to the double point, that is if the exponent of a factor is even, then the point is called the double point. The curve remains located on the same side of the number line. I hope you are able to relate. Correct, na, dear students?
Yes.
Okay. Then what is the step 4? Now step 4 is pretty simple. Let me first put the step 4, then let me explain. Now, to find the solution to fx greater than 0, choose the appropriate open intervals where the wavy curve is positioned above the number line. And to find solution to fx less than 0, choose the appropriate open interval where the wavy curve is positioned below the number line. Correct, dear students? That is step 4. And that is done. After that, what we will do? Here are the following points to be, taken care, and these points I'm just going to mention it. So here the following points to be noted. First one, the value of x for which the denominator of fx is 0 will not be included in the answer, as for all these values of x, fx is not defined. You remember? That's why for the points where the denominator is 0, we make it unmarked circle, unfilled circle, and always you took the open interval, na, dear students? That is the reason. You can always go back. Do you want me to explain this thing? If you look into it here, -3, -2, -1. These are the points for which the denominator is 0, and denominator 0 is undefined, na? That's why in the solution we'll never include all these points, -3, -2, -1. You see, that's why all these things are actually open interval, na, dear students? -3, -2, -1. Correct, na, dear students? Got it? And that is why I wrote this point. Now, if we go back, what is the second one? Second one is something like this. Just a minute, let me increase the font a little bit and come back. In case to find solution for fx greater than equal to 0 or fx less than equal to 0, then make the intervals closed corresponding to the roots of the numerator and make the intervals open corresponding to the roots of the denominator. I hope you got the point, dear students, that we have done, right? So when it is greater than 0 or less than 0, greater than equal to 0 or less than equal to 0. If you see here that fx less than 0, we found this solution. Fx less than 0, we found this solution. But when fx is less than equal to 0, we included one open interval was there, we made it to closed interval. 2 open interval was there, we made it to closed interval. 3 open interval there, we made it to closed interval. Why? Because 1, 2, and 3 are the points for which the numerator is 0. But for the denominator points, we kept as it is like less than 0, like -3, -2, and -1. Because for -3, -2, and -1, if we apply, the denominator becomes 0. Correct? And it is undefined, so we should not include those points. That is why it is the open interval. Correct, na, dear students? So what will be your task now? I am done. Your task should be, go back to this theory again very well. Look into these video lectures, that whatever I am recording now, it will be available to you in another 1 hour, maximum another 1 hour. Look into this. Look into all the worked out problems of what I have done, and then start solving the 3 exercise questions I'm going to give you now, dear students. So these 3, you need to solve it and send me your solution. Okay. So 3 exercises I'm going to give you now. These 3 exercises solutions, you need to send it to me before we start our class on Monday. Is it clear, dear students, what I'm saying?
Yes.
Along with that, you need to solve, another 2 DPPs. As it is, DPPs are our continuous effort till we are completing all the DPPs for the relevant chapter. So what are the exercise I'm going to give you now, dear students, is something like this. And I hope you will, enjoy doing it, because this is the first one. And not only that, when I'm saying it is that enjoy doing it, there is a proper meaning. If you do not enjoy doing it, you can let me know. You can express that is the reason I didn't enjoy it. No worry about this thing. We'll see. Sometimes we may not able to, like some topics, but at that time, what you need to do, you need to, make more understanding with your teacher and make things in your favor. Okay. So these are the 3 exercises. You need to solve it and send me your solution before we start our class on Monday. Correct, students? With this, I would like to conclude the class for today. If you have any specific question, you can feel free to me, or you can be in touch with me throughout the day, over WhatsApp, phone call, email, whatever. Thank you very much. And our next talk is on Monday. So till Monday, you need to solve these 3 exercises and 2 DPPs from the online platform www.KonarClasses.com. Thank you very much.
Thank you.